Which one of the following statements is wrong? Option B is wrong. In power MOSFET, the channel length is relatively large and width is relatively small, which is wrong. As channel length is represented by diode current, that is directly proportional to width by length. So in power MOSFET, as current is small, width will be small and length will be large. Power MOSFETs are usually majority carrier devices, so they do not experience any minority carriage storage. Power MOSFET, they can operate in parallel to handle very high currents. So in parallel circuits, the current will be divided into different paths, so that when the source current is very large, it will be divided into different number of parallel paths, so that it can handle very large currents. Power MOSFET is positive temperature coefficient device and it is a voltage controlled device. An SCR, silicon control rectifier, is rated for 650 volts, which is the peak inverse voltage. He is asking what is the voltage for which device can be operated if voltage safety factor is 2. Here the voltage safety factor is nothing but the safety factor which is used to protect the SCR. Here V maximum, you can write it as peak inverse voltage by safety factor. Both are given in the question. Peak inverse voltage is 650 and safety factor is 2. You will get maximum voltage 325. RMS voltage is maximum voltage divided by root 2. Structure obtained by lightly doped in drift region between the layers of a PN junction. A pin diode is obtained. This structure is effective in making the diode support large reverse blocking voltages is the right answer, because in drift region lightly impurities are added. So drift region is the region which is used to increase reverse blocking capability. So by lightly doping in drift region, its reverse blocking capacity will increases and it will have large reverse blocking voltage. Consider the following statements. A thyristor requires turn off circuit while transistor does not require any turn off circuit. The voltage drop of thyristor is less than that of transistor. No, the voltage drop of thyristor is more than transistor. A thyristor requires continuous gate current, which is wrong. It requires only gate current during turning off of a thyristor. A transistor draws continuous base current, as it is right. Among triac SCR MOSFET IGBT, MOSFET is the fastest switching device, so its time is less, that is 5 to 10 microseconds. Next, IGBT is second fastest switching device, so its time period is 50 to 100 microseconds requires to turn on. Next, third goes for SCR and fourth triac requires 200 to 400 microseconds, which is slowest device among all devices. So among these devices, MOSFET is fastest and triac is the slowest device. Turn on time of an SCR can be reduced by using rectangular pulse width of high amplitude and narrow width. Turn on time depends upon delay time, rise time and spread time. This delay time must have high IG, high rate of rise of gate current. Rise time has low time constant and spread time depends upon the geometric construction. So overall on time can be reduced by having high amplitude and narrow width. Snubber circuit used to shape the turn-on switching trajectory of thyristor and or to limit di by dt during turn-on. See, to limit the di by dt, we need an inductor in series with an SCR, and to limit di by dt turn on, we need LR snubber unpolarized. According to the ESC 2014 key, the answer is LR snubber unpolarized. To limit the di by dt, we need an inductor in series with SCR. Inductor does not have any polarity, but as per Ankit Goel, answer is LR snubber polarized. In an IGBT cell, the collector and emitter are respectively. Collector is P plus, emitter is N plus. IGBT consists of base, emitter, collector. IGBT has continuous base current, and collector will be P plus, emitter will be N plus. Consider the following statement with regard to power diodes. The breakdown voltage is directly proportional to doping density of drift region, which is a wrong statement. The breakdown voltage is inversely proportional to the doping density. Losses in the diodes are less due to conductivity modulation of the drift region in the on state. Due to conductivity modulation, R on decreases, conductivity increases. As losses are I square into R, as resistance decreases, losses in the diodes also decreases. The vertically oriented structure supports large blocking voltages, which is a wrong statement. Vertically constructed structure supports large blocking currents, not voltages. So option 2 is right. Reverse recovery time of diode is 3 microseconds and rate of fall of diode current is 30 amperes per microsecond. The storage charge QRR and peak inverse current IRR will be QRR is equals to 1 by 2 into TRR square into di by dt. In the same way, IRR is equals to TRR into di by dt. Or you can write IRR is equals to dq by dTRR into dt. In BJT, due to current flow to small portion of base, hot spots are produced, causing localized excessive heating and damaging the transistor. The switching limit is called secondary breakdown. Lightly doped M epitaxial layer is present in PN junction diode. Statement 2. Power diodes have lightly doped N epitaxial layer which can absorb the depletion layer during reverse base. So power diodes during reverse base will absorb the depletion layer. So both statements are true and 2 is the correct explanation of A. The regenerative action that does not take place in which type of triggering methods to turn on SCR? High forward voltage triggering. In this, the regenerative action does not take place to turn on SCR. Which one of the following is circuit symbol of P channel IGBT? Option D is right. This body is N type and current is moving outwards. Which one of the following is not the advantage of solid state switching of AC capacitors into AC supply over relay based switching? In case of solid state switches, the switching is faster, so it will have more transients. So low transients, which is not the right answer. So answer is A. Which one of the following statement is correct? The turn-off time of converter grade SCRs are normally in the range of 50 microseconds to 200 microseconds. Converter grade SCRs whose speed is suitable to use in phase controlled converters are the converted grade SCRs, and the turn off time is about 50 to 200 microseconds. The total harmonic distortion of AC supply input current of rectifiers is maximum for. First of all, total harmonic distortion represents the amount of harmonics present in the rectifiers. In the given options, single phase diode rectifier with capacitive filter is the right answer, because single phase diode rectifier has more harmonics as compared to the three phase rectifiers. As pulse numbers increases, harmonic decreases, and with the capacitive filter it will smoothens only voltage waveform and creates more ripple or discontinuous in the current waveform. So he is asking now amount of harmonics in the input current, as amount of harmonics are more in single phase diode rectifier with capacitive filter. The characteristic features of discontinuous conduction compared to the continuous conduction in a two pulse single phase bridge converter are. Option A is the right answer, because since it is a single phase bridge converter, it has larger average value of load voltage, because voltage does not become negative in the bridge converter, and it has large ripple content due to the discontinuous conduction. The average output voltage of a flyback converter is V0 is 24 volts at resistive load 0.8, duty cycle is 50% and switching frequency is 1 kHz. The on-state voltage drop of the switch, transistor and diode is 1.2 and 0.7. The turns ratio of transformer is NS by NP is equals to 0.25. What is the efficiency of a transformer? First of all, he is talking about the flyback converter. Flyback converter is nothing but SMPS, switching mode power supply, and he is asking to find the efficiency of a converter. Efficiency is nothing but output power by input power into 100. Output power is V0 into I0 by Vs into Is. Here he has given V0. We have to find the I0. I0 is equals to V0 by R. You will get 24 by 0.8. You will get I0 is 30 ampere. So here the circuit will look like this. It consists of an input voltage in series with an transformer and a switch, and secondary of a transformer is connected to the diode and a capacitive filter with a parallel with resistive load. Now to find Vs, voltage across the switch, here we will do KVL equation on the secondary side. You will get to find the voltage across the secondary of a transformer, we will do KVL equation on the secondary side. By doing KVL, you will get Vs is equals to 24.7. Now you have got secondary voltage. To find the primary voltage, use the turns ratio of a transformer. So Vin can be found out by Vin is equals to primary turn by secondary turn into secondary voltage plus switch voltage. Already in question switch voltage is given as 1.2 volts. So by calculating you will get Vin is equals to 100 volts. Now I0 is equals to 30 amperes. We know efficiency is output power by input power into 100. Output power is nothing but V0 square divided by R. You will get 720 watts. By using the turns ratio of a transformer, you can also find input current, where input current is inversely proportional to turns ratio. input current by output current is equals to secondary turns by primary turns. You will get 7.5. So by calculating efficiency, output power is 720 divided by input power is Vs into Is. Vs is nothing but V in 100 into I in is 7.5. You will get 96%. So overall in this problem, the problem revolves around the turns ratio. By having the turns ratio, you can find the input voltage, input current and efficiency of a switching mode power supply, which is nothing but a flyback converter. A single phase 2 pulse converter feeds a load which is with insufficient smoothing, but conduction is continuous. If resistance is increased, then what will happen? Here the words insufficient smoothing means it has ripples and inductance is not very large. So as we increase the resistance, tau is equals to L by R. As resistance increases, time constant decreases. So inductors charges and discharges within a short time, means faster. When the inductor charges and discharges very fast, there will be more ripple content. So, and if inductor fully discharges, there will be discontinuous of a conduction. Inductance does not allow the supply to become discontinuous. So as inductance get fully discharged, there will be discontinuous conduction. So option D is the right answer. There is a possibility of discontinuous conduction because inductor gets fully discharged, and due to increase of resistance, time constant decreases and inductance will charge and discharge faster. So there will be more chance of having the ripple content more, increase in the ripple content. For large power output, multi-phase rectifiers are used along with filters to reduce level of harmonics by increasing the fundamental frequency in A. Diode rectifier, B. Bridge rectifier, C. Star rectifier, D. Delta rectifier. Answer is C. Star rectifier. While finding various factors of single phase diode rectifiers, the transformer utilization factor of half wave rectifier is transformer utilization factor is represented by PDC by Vs RMS Is RMS. PDC can be written as VDC into IDC, that is Vm by pi into Vm by pi r, where supply RMS is Vm by root 2. So, voltage, supply RMS current is output RMS voltage divided by R, where output RMS voltage, supply RMS voltage is equals to output RMS voltage is equals to Vm by 2R. You will get answer as 2 root 2 divided by pi square. Here the only difference is supply RMS is Vm by root 2, where supply RMS current is output RMS voltage by R, where output RMS voltage of a half wave rectifier is Vm by 2. So output RMS current is equals to output RMS voltage divided by R, that is Vm by 2R. The function of capacitive filter in Grade's diode bridge rectifier is to answer is reduce harmonics in the rectified output signal. When capacitor is connected across the load resistance R, ripple current passes through the capacitors and only smooth current passes through the load resistance. So it smoothens the output voltage waveform and bypass the ripples to the capacitor. Use of inductive filter in a rectifier circuit provides satisfactory performance only when load current is low. When load current is low, inductive filter is used in the rectifier circuit, and when load current is high, capacitive filter is used in the rectifier circuit. AC to DC controlled rectifier to operate in regenerative mode. Which of the following conditions should be satisfied? Regenerative mode represents the power is fed back to the supply. It acts as an inverter. So answer is full controlled bridge rectifier with alpha firing angle greater than 90 degrees. Source of EMF in load. It cannot act as a semi-converter because semi-converter operates only in motoring mode, that is in first quadrant. So semi-converter cannot be inverter. So it will be full controlled bridge rectifier. Half controlled bridge rectifier represents semi-converter. So it cannot be semi-converter and alpha must be greater than 90 degrees. 6-pulse SCR converter is connected to 230 volts 3-phase 50 Hz AC mains and is controlling a DC drive with terminal voltage 205 volts and rated current is 105 amperes. Commutation angle is given as 18 degrees and firing angle is given as 45 degrees. He is asking what is the rating of shunt compensator and power factor. We know power factor formula as cos phi is equals to P by S. S represents under root P square plus Q square. P represents the output power, which is V0 into I0 given in the question 205 into 105, which is 21.525 kilowatts. Fundamental displacement factor formula is cos of alpha plus mu by 2, where mu is halved in the argument of cos. So cos of alpha plus half of mu, which you will get it as 0.587. Q alpha is P tan alpha and Q with respect to mu is P into sin mu by mu minus cos mu. You will get 0.7011 kVAR. So total reactive power is 22.26 kVAR. Power factor is P 21.525 divided by under root of P square plus Q square. You will get 0.695. This type of questions may not ask in AE exam because we need Cal C to calculate these questions. So it is better to remember what is the procedure he is doing to calculate the problem. Two fully controlled 3-phase bridges are connected in anti-parallel across a load to provide reversible DC voltage to load. The bridges operate in circulating current mode. The input is 3-phase 440 volts 50 Hz AC supply. Maximum load current is 30 amperes. Peak value of circulating current is 6 amperes. He is asking to find the value of inductance to limit circulating current. Hence, to limit the circulating current, the capacitor peak current must be shared between two converters. So actual current is 6 amperes. If this 6 amperes is shared between the two converters, it will become 3 amperes for each converter. Now total current of single converter is already having the maximum load current 30 amperes plus current of each converter is 3 amperes. You will get 33 amperes. Now you know I is equals to Vm by 2XL, as it is actually the formula of current is Vm by Z. Z is equals to XL. But here these two converters are connected in parallel, so we will take Vm as 33 is equals to Vm by 2XL is the formula to calculate the value of inductance. By substituting the values of current 33, VML is root 2 Vs, that is root 2 into 440 divided by 2XL. You will get answer as 30 milliamperes. 3-phase semiconductor, if firing angle is less than or equal to 60 degrees, then duration of conduction for each thyristor and diode both will be same 120 degrees, because for alpha less than or equals to 60 degrees represents continuous conduction. Here freewheeling diode will not conduct. So thyristor and diode conducts for same time period, so for same firing angle of 120 degrees. Line commutated phase control inverter is operating at its inverter limit. Commutation failure happens. Generally the commutation failure happens when time is less available. When time is less available for commutation, the commutation takes place very fast and there will be failure of the commutation. So slow commutations have less failure and fast commutations have more failure. So commutation failure happens because the commutation is very fast and it has less time available for commutation, so time period is less and frequency is high, so frequency increases. Consider the following statements. The voltage developed across off switches of half bridge converter is maximum DC voltage. See, in the circuit which was drawn by pink color, the voltage is divided into two voltages. Half of one voltage is VDC and down voltage is also VDC. When upper switch is turned off, the voltage across the switch will become supply voltage, that is VDC. So first statement is correct. In full bridge converter, it consists of two diodes and two switches. The voltage across the primary of the transformer is DC link voltage. Here he have mentioned output voltage is plus or minus VDC. The transformer will be connected at the output of the inverter. So statement 2 is right. Statement 3 is wrong because the voltage developed across the off switches of the full bridge converter is half the maximum DC link voltage. No, it is a wrong statement. In comparing the operation of half controlled 2-pulse circuit with that of fully controlled circuit, which of the following statements are evident? Half controlled 2-pulse circuit represents single phase semi-converter and full control circuit represents single phase full converter. Since full converter has 4 thyristors, semi-converter has 2 thyristors and 2 diodes. Since 2 thyristors are replaced by 2 diodes, this semi-converter is less costly than full converter. First statement is right. In single phase semi-converter, there will be a freewheeling action. Due to this freewheeling action, output voltage never goes negative and area of output voltage increases. As area of output voltage increases, output power increases and power factor will be high. So due to freewheeling action with half controlled bridge rectifier, power factor is higher in half controlled converters. Third statement is the AC supply current is more distorted due to its 0 rates with half control circuit compared to fully controlled bridge circuit. See, he's saying about the harmonics. Harmonics are inversely proportional to pulse number. As single phase semi-converter is consist of 2 pulses, this full control circuit converter has more number of pulses than single phase semi-converter. As single phase semi-converter has less pulses, then it will have more harmonics compared to that of fully controlled bridge circuit. So due to more harmonics, this AC supply current is more distorted in single phase semi-converter compared to that of fully controlled converter. In line frequency phase controlled converters and single quadrant step down switch mode DC to DC converters, the output converter current can become. Answer is discontinuous at light loads on motor. First of all, at light loads, if the load is less, then power is less. We require less power. If we require less power, we require less current. If current is less, inductor may completely discharge. When the inductor is completely discharged and it becomes null, it will be in the discontinuous conduction. So the output current is discontinuous at light loads on motor. In buck boost converter, what is the maximum value of switch utilization factor? Switch utilization factor can be represented by output voltage into output current by switch voltage peak value into switch current peak value. Output voltage of buck boost converter is dVs upon 1 minus d, and output current is I0, where switch peak voltage is supply voltage plus dVs upon 1 minus d, where switch peak current you can write it as I0 upon 1 minus d. By calculating the above values, you will get switch utilization factor as d into 1 minus d. So in examination point of view, in buck boost converter, if he asks about the switch utilization factor, directly remember d into 1 minus d. So to get maximum value of switch utilization factor, now derive d with respect to d into 1 minus d and make it as 0. You will get d as 1 by 2. So switch utilization factor you will get, if you substitute 1 by 2 into 1 minus 1 by 2, you will get 1 by 4. So the answer is 0.25. So for buck boost converter or buck boost chopper, switch utilization factor is 0.25. Forward DC to DC converter requires a minimum load at output. Statement 2. Without minimum load, excess output can be produced. So in this option, both statement 1 and 2 are true, and 2 is the correct explanation of A. A boost converter having an input voltage of 20 volts is connected to a resistive load. Inductance value is given as 1 millihenry with an series resistance of 0.1 ohm. Duty ratio is 1 output voltage. Whenever an inductor has a series resistance, then D is equals to 1, output voltage will be 0, because output voltage can be represented as output voltage is equals to input voltage by 1 minus D plus capital R by small r into 1 minus D. When D is equals to 1, denominator will become infinity. When something by infinity, it will become 0. Therefore, the output voltage is 0. In list 1, A option represents 3, which is a stepped waveform. It is a phase voltage of a 3-phase inverter with 180 degrees conduction mode, and input voltage is DC voltage E. And option B represents 4. This is a rectangular wave, so it represents 3-phase diode bridge rectifier. And option C represents 1, which represents single phase fully controlled AC to DC converter. And option D represents 5, which is pulsating in nature. It is a 3-phase diode rectifier. And option B represents 4, which represents line voltage of a 3-phase inverter with 180 degrees conduction mode. So option B represents 180 degrees conduction mode, where stepped waveform is a phase voltage of a 3-phase inverter. This square waveform, which is a line voltage of a 3-phase inverter with 180 degrees conduction mode. Similarly, in 120 degrees mode, it will be opposite. Stepped waveform will be line voltage of a 3-phase inverter in 120 degrees conduction mode, and square wave voltage will be phase voltage of a 3-phase inverter in 120 degrees conduction mode. McMurray inverter diodes are connected in inverse parallel to thyristors. Means he is saying about RCT, in which diodes and thyristors are connected in anti-parallel. It is used to make turn off of thyristors successfully. Diode reverse base అయినప్పుడు the diode reverse base, if the diode gets reverse base, it also of the thyristor and the SCR due to anti-parallel connection. Diode gets reverse based the SCR due to anti-parallel connection. It provides path to reactive component of load current. When current lags voltage, current flows in reverse direction across diode helps, and the diode helps the current inflow. So both 2 and 4 are right. Modulated inverter for the control of AC motor is fed from which one of the following? A. Controlled rectifier, B. Uncontrolled rectifier, C. AC regulator, D. Cycloconverter. The answer is uncontrolled rectifier. The pulse width modulation control for controlling the motor is fed from uncontrolled rectifier, because in uncontrolled rectifier output voltage can be controlled using pulse width modulation, but in controlled rectifier there is no control or no pulse width modulation control Vin to vary output voltage. So answer is B. Which one of the following course is used for large main transformers to reduce eddy current loss of high frequency operation in power electronic circuit? That is C. Compressed ferromagnetic alloy core. Single phase full bridge inverter. What is the advantage of unipolar switching over bipolar switching? Answer is C. Apparent doubling the switching frequency. See, unipolar switching change of voltage is V, and in bipolar switching it is a continuous square waves which is 2V. Modified McMurray full bridge inverter works on current commutation. In sinusoidal pulse width modulation, the width of each pulse is varied in proportion to amplitude of sine wave evaluated at the center of same pulse. The RMS value of output voltage can be varied by varying the modulation index, where modulation index is V sine by V carrier. For linear modulation, MA will be less than 1, and for overmodulation, MA will be greater than 1. So both statement 1 and 2 are right, and 2 is the correct explanation of A. Which one of the following statements is right about the series resonant inverter? The trigger frequency is higher than the damped resonant frequency. Where damped resonant frequency, you can write it as omega D. Omega D is equals to omega R under root 1 minus 2 eta square. This frequency is less than the triggering frequency. Motor armature supplied through phase controlled SCRs receives a smoother voltage shape. Answer is at high motor speed. As firing angle decreases, output voltage increases. As output voltage increases, harmonics gets reduces. High voltage means speed is very high. If we use high pulse number, output voltage increases. As pulse number is inversely proportional to harmonics, harmonics get reduced and speed gets increased. A large DC motor is used to control the speed of blower from a 3-phase AC source. Which is the most suitable converter? Answer is 3-phase half controlled bridge converter. It is nothing but 3-phase semi-converter which operates only in first quadrant, that is only motoring mode. While going to option A, 3-phase fully controlled bridge converter, it operates in first and second quadrant, in which voltage is positive but current is will be positive in first quadrant and will be negative in second quadrant. In first quadrant it acts as motoring mode. In second quadrant it acts as, due to reversal of current, it is regenerative braking mode. So no freewheeling action takes place. So the right option for this question is option C, because the blower needs only one direction of current, positive direction of current and positive direction of voltage, so it operates in only motoring mode. So three-phase half control bridge converter is the right answer. Separately excited DC motor is started using three-phase AC or DC control rectifier using soft starting. For limiting starting current, it is required that firing angle should be. So to limit the starting current, we will not add any external resistance, but we will reduce VT to reduce terminal voltage, which depends upon cos alpha. As alpha reduces, VT increases. So firing angle gradually reduced from 180 degrees to 30 degrees. Wound rotor or slip ring asynchronous motor is commonly used as drive in overhead cranes and load equalization. Which of the following speed controls is adopted? Static rotor resistance control. By means of chopper, it is used in overhead cranes and load equalizations. SMPS, after conversion of AC supply to high filtered DC voltage, a switching transistor is turned on and turned off at high speed by pulse width modulation, which generates high frequency square pulses. What is the frequency of these pulses? That will be 20 kHz to 50 kHz. What are the advantages of switching power supply over linear power supply? Option 2 and 3 are right. The device operates as switches to turn on and turn off, and the power loss is less, which is the important thing in switching power supply. For the isolated buck boost converter as shown in the circuit below, the output voltage is to be 35 volts at duty cycle 30%. The input voltage is obtained from front end rectifier without voltage doubling, fed from 115 volts AC. What is the peak forward blocking voltage of the switching element? Now consider the switch is off and diode is on. When switch is off, switch is open circuited and you will get voltage across the switch. Input voltage is 115 times root 2, which is 162.6. Output voltage is given as 35 volts. Now to find the input voltage, we will use the turns ratio of a transformer. Here output voltage by input voltage is equals to secondary turns by primary turns into D by 1 minus D into Vin. So by this you will get secondary turns by primary turns. So or else V primary by V secondary is equals to NP by NS into secondary voltage is 35. You will get 69.7. To find voltage across the switch, you have input peak voltage is 162.6 plus primary voltage across the primary turns of a transformer is 162.6. You will get 232.3 volts. Consider the following features with respect to flyback converters. It is used mostly in applications below 100 watts, which is right answer. Flyback converters are used for low power applications and it is also used for low voltage applications. So second option is wrong. It has very low cost and its construction is very simple. So option 1 and 3 are right. A unified power supply is driving a 600 watts load which has lagging power factor 0.8. Efficiency is given as 0.8. Battery voltage is 24 volts DC. Assume that there is a separate charger for the battery. What is the rating of inverter? Rating is nothing but he is asking about the apparent power. apparent power is equals to real power by power factor. You will get 750 volt ampere. Here the note point is inverter only supplies power to the load and it does not supply to the batteries. In DC power supplies, the switching frequency is much greater than the AC power source frequency, enabling the transformer to be small. As frequency is high, size of the transformer is less. Cycloconverter is operating on a 50 Hz supply. The range of output frequency that can be obtained with acceptable quality is answer D is the right option, where it is 0 to 128 Hz. An integral cycle AC voltage controller is feeding a purely resistive circuit from a single phase AC voltage source. The current waveform consists alternately burst of N complete cycle of conduction followed by M complete of extinction. The RMS value of load voltage equals the RMS value of supply voltage. For M is equals to 0. AC voltage regulator is on for N cycles and it is on for M cycles, and load voltage is equals to supply voltage. That means it will never become off. So extinction angle M will be 0. M is equals to 0. In closed loop control of squirrel cage induction motor, the field oriented control strategy implemented is, it is a vector control. This you have to remember.